Alright, we're going to try something new here today. So what we're going to do is we're going to use these videos to kind of let you learn at your own pace. What that means is if you want to pause the video to take notes, you pause to take notes. If you need to go back and see an explanation again, you go back and see an explanation again. I'm going to have you guys work on some problems, and when I do, I'm going to tell you to pause. You'll pause the video, work the problems out. When you hit play, we'll talk about the answers. Alright, let's give this a try. Today we're going to be talking about similar polygons. And we did a little bit with that earlier in the year when we did dilations. So I think you guys are going to do very well with this. So the first thing was similar polygons. When we gave me a symbol for similar. And it's kind of like the symbol we use for congruent. It's just the top part of the congruent symbol. Just that top wavy line. So we can write triangle ABC as similar to triangle DF. And just a shortcut is this little wavy tilde. Now, there's a couple cool properties of similar polygons. Now, since we know similarity transformations preserve angle measure, that means that the corresponding angles are congruent, just like in congruent figures. Now, also, a similarity transformation enlarges or reduces side lengths by a scale factor, which is k, which means all the corresponding side lengths are also proportional. And what that looks like is angle C will be congruent to angle F, angle A is congruent to angle D, angle B is congruent to angle E. And all the matching side lengths are multiples of this scale factor K. So the ratio of side lengths DE over AB equals EF over BC equals FD over CA, all reducing to that scale factor K. Alright, let's do a problem together. So in this diagram, triangle RST is similar to triangle XYZ. So the first thing we're asked to do is find the scale factor from RST to XYZ. Since triangle RST is mentioned first, this goes in the numerator, and XYZ is second, and it goes in the denominator. So what we're going to do is we can say RT over XZ is 25 over 15, that reduces to 5/3. TS over ZY is 30 over 18. That simplifies to 5/3 also. And lastly, RS to XY is 20 over 12. We divide by 4. That simplifies to 5/3. These all are 5/3. That means the scale factor K equals 5/3. Next, we list the pairs of congruent angles. That's fairly simple. All we're going to do is R is first, X is first. So angle R is congruent to angle X. S and Y are second. So angle S and angle Y are congruent. And lastly, T and Z are last, so angle T is congruent to angle Z. Now we're going to write the ratio of corresponding sides, which is also the same words. It's a synonym for statement of proportionality. And our statement of proportionality, what we're going to say is we're going to say RT over XZ equals TS over ZY equals SR over Y. So we're just kind of taking these three parts and saying them equal to each other. Alright, so here's a problem for you guys. I'd like you to pause the video now and work on it on your own. And we're back. So, the scale factor, we write KL over QR, 4/6 is 2/3, LJ over RP, 8/12 over equals 2/3, and JK over PQ is 6/9 over equals 2/3. So K, our scale factor, is 2/3. The angles, angle J is congruent to angle P, angle K is congruent to angle Q, and angle L is congruent to angle R. Our statement of proportionality, KL over QR equals LJ over RP equals JK over PQ. So we're just like taking these pieces. Hopefully we did alright on that. Alright, next problem. Now the cool thing, the corresponding lengths in similar polygons, so once we know two polygons are similar, any of the two corresponding lengths are going to be equal to the scale factor of the similar polygons. That means not just side lengths, but altitudes, medians, mid-segments, and other pieces like that. So we're going to use that to find this missing side X over here. So what I want to do, what I always like to do, since DEF is first, I'll put something from here on the numerator and MNP in the denominator. So MN is going to match DE. So I'm going to do 18 over 15 equals, now I want to get X in here. So since X is in part of the triangle with 15, X goes in the denominator. And X matches 30, so 30 goes in the numerator. Now what I usually like to do, you could just cross multiply and divide, but that's a little harder than it needs to be. I'm going to simplify this fraction. 18 and 15 divide by 3, I get 6 and 5. And again, you could cross multiply and divide. 5 times 30, 6 times x. I like to do this a little more clever. I go, alright, 6 times 5 gets me 30. So that means 5 times 5 will get me x. And 5 times 5 is 25. So x is 25. Alright, let's try another problem. So now here, we're dealing with altitude instead of like one of the side lengths. We know the triangles are similar, so we're going to use that to our advantage. This whole side length TR is 12. This whole side length XZ is 16. So I'm going to write 12 over 16 equals, I don't have anything here, so we'll make that y. So since y is in the same triangle as 12, y goes in the numerator, and 20 goes in the denominator. Again, I'm going to simplify this. These both divide by 4, I get 3/4. And I go, alright, well, 4 times 5 gets me 20, times 5 again. So 3 times 5 will get me y, so y equals 15. And we could have done 3 times 20 is 60, 4 times y and divide by 4. We would have got the same result. Alright, so here's a couple problems. I want you to find the value of x, find the length of km. Alright, so pause your videos, and we'll be back in a moment. Alright, so I've got my starting proportion. I'm just going to work through it with you. Now, I didn't have to use 10 over 5. I could use 16 over 8, could use 12 over 6, as long as I have a matching pair. So anyway, 10 over 5, I'll simplify. 10 over 5 is 2 over 1. So I do 1 times 4 is 4. So 2 times 4 gets me 8, so x equals 8. Let's try this one. Alright. So 48 and 40 I can divide by 8. So I get 6/5. And then 5 to 35 is times 7. So I'll do 6 times 7, and I'll get y equals 42. We could have done 5y equals 6 times 35 and worked it out. This way is a lot faster and more elegant. Now there's some cool properties about the perimeters and the areas of similar polygons as well. Now the perimeters of similar polygons are going to be, the ratio of the perimeters rather, is going to be equal to the ratio of the side lengths, equal to that scale factor. So this is like a really great shortcut we're going to be able to use. So this is saying add up all the sides, add up all the sides. That ratio is the same as any ratio between the two sides, as long as we know the triangles, or the polygons rather, are similar. Let's give that a whirl. Alright, town plans to build a new swimming pool. That sounds fun. An Olympic swimming pool is rectangular with length of 50 meters and 25 meters. So here's our Olympic swimming pool. There's Michael Phelps over here, ready to dive in. And a new pool is going to be similar in shape, but it's going to be a little shorter. Maybe they didn't have enough room. We'll have a length of 40 meters. So I'm going to draw this a little shorter guy. And label that length 40 meters. I want to know the perimeters of the Olympic pool and the new pool. So I don't really have a lot to go on. I don't even know what this side length is. But that's okay. I don't need it. So for the perimeter of the Olympic pool, well, you guys know how to do that. 50 plus 50 is 100. 25 plus 25 is 50. So the Olympic pool is equal to 150 meters. And now I need to find the perimeter of the new pool. I guess maybe we're going to figure out how to tile it or whatever. So what I need to do is I need to set up a proportion. Now I know that the lengths and the perimeters are going to have the same ratio. So I'm going to use that to my advantage. So I'm going to say that 40 over 50, so my new pool over the Olympic pool, is equal to, now I don't know my perimeter, so I'm going to put P, and that's going to be over 150. Again, what I'm going to do is I'm going to simplify. I'm going to divide both these by 10. So divide by 10, you get 4/5. So 5 times 30 will get me 150. So 4 times 30 will get me my new perimeter. This perimeter equals 120 meters. And again, this is much faster than doing 40 times 150 and doing that long division. So be clever with your work. All right, here is a problem for you to work on. I think you guys can see that. So I want to find the perimeter of gazebo A. I want you to pause your video. And so hopefully you found the perimeter of gazebo B. Add all these up, you got 69 meters. So our proportion, we're going to match up 10 to 15, 10 over 15 equals our new perimeter for gazebo A over 69. I'll simplify this. Divide by 5, I get 2/3. And I see that 3 times 23 gets me 69. So I'll do 23 times 2, and I get my new perimeter is 46 meters. Hopefully that worked out well for you. All right. So let's look at areas of similar polygons. Now this is a little different ratio. If two polygons are similar, then the ratio of the areas is equal to the squares of the ratio of side lengths. Essentially what that means is when two similar polygons have a scale factor k, the ratio of their areas is equal to k squared. So we're going to have to do a little bit of extra work here. Alright, so let's see. We know triangle ABC and triangle DEF are similar. We want to find the area of DEF. So what I can do is I know the ratio of the areas is equal to the ratio of the sides squared. What that means, I'll set up 10 over 5. Now I got to square this ratio is equal to, now this is 36. And I'll just label that A. Now we can simplify just like we were doing before. I always like simplifying, it makes my work so much easier. So this is going to be 2 over 1. So I'm going to get 2 squared is 4 over 1 equals 36 over A. So 4 times 9 gets me 36. So that means 1 times 9 will get me N. It'll give me A rather. So A equals 9 centimeters squared. Just like that. Not so bad. Alright, why don't you guys try this one, and we'll be back to talk in a moment. So I set the ratio of my sides, squared it, and that's going to be equal to the ratio of my areas. I did small over big here. So 7 and 21, I certainly don't want to be squaring 21, so I'm going to simplify both of these. Divide by 7, I get 1/3. So what that means is I can square this. So I get 1 over 9, let me scroll down a bit. 1 over 9 equals 84 over A. Alright, so I guess that what that means we need to do is 1 times 84 gets me 84, so I gotta do 9 times 84. So let's do that. Just do that right like this. So we'll say that 9 times 4 is 36. 9 times 8 is 72, plus 3 is 75. So this area equals 756 meters squared. Alright, hope you got that.